Mastercam file. But we need to finish programming it manually. Got just a little bit of time left to do that, and then I wanted to spend some time talking about the page 80 homework. Let's see. So let's go back to our spring housing. So it's way easy. It's way more fun to click on lines and things. But the fact is, Mastercam, I don't know how much it costs, but it's got to be easily $15,000-$20,000, and then a couple $1,000 a year maintenance fee. And I'll try to bring home one of my Heidenhain programs and show you guys the difference. Because programming that 5-axis would be pretty near impossible without Mastercam. So, all right. So we have rapided out of this hole, and just like in Mastercam, we want to run over to this corner and start our geometry. Now we're gonna program like computer or control, because we don't want to have to program the cutter path, because that way we'd have to trig out all these angles, which is a serious pain. If you guys remember the kind of obnoxious trigonometry attempt at trigonometry lecture that I did. But what I'm going to do is I'm going to write these points down on this piece of paper, so that when I'm going around, it's hard to do. I had a little app that I was using for a marker board, but it keeps crapping out on me. So I guess we could do it in Mastercam, but I'll just write these points down. So we're going to be 1.690. So I'm just going to draw a little rectangle, much like this, and then write all my points on there. The width, our overall width is 2.630. So we would just take 2.630 divided by 2 is 1.315. So from the center to the edge is 1.315. Minus 30 thousandths for the chamfer. Oops. Did I say 315 or 313? 315. 1.315 minus 0.030 is 1.285 to this chamfer. All right. This is Y0. And then the quarter of the chamfer is Y minus 0.030. And just for saving time, because we spent so much time on Mastercam, we'll just go around this thing once. So 1.690, maybe we could like make the homework. You guys plan, I'll program the finish pass. You guys pop in a rough pass. And then, yeah, we'll see how that goes. Y minus 1.690. And then that plus 0.030 will be this corner, if that makes sense. Minus 0.030. So Y minus 1.660 is this corner. So the beauty of this programming off center is the X values are just plus and minus and just kind of still the same. All right, so we're going to wrap it. So we finished up at on this bore, and check the comments. Okay, I'm gonna run around this, and right here will be your add rough pass. I'm looking for my star. But we'll pretend that you went around it once in the rough pass. And I'm going to come in here and say, okay, so we want to start over at, if our clearance is at, well, it's at 1.285. So 1.315 is this edge. So 1.315 plus 0.350, or wait, we got 3/4 cutter. So half of that would be 3/8, and we'll just say x 0.450. X 0.475, that'd be 100 away. So 0.475 plus the side of this right here is going to be 1.315 x minus 1.790. That's not what I wanted to happen. X minus 1.790 and y, we'll just put it at y0 and we'll come around it, mill all our little angles. And last thing, we'll have to remember to mill that last angle. Y 0.375 or y 0.475, which is half the cutter plus 100 thou. All right. Enter. I'm going to just add a couple enters here, and I'll resave this over the old homework. And we'll say we're at z.1. Say g1 z minus. So we're going to want to go past this. We'll just go to the same z minus 1.050 so that we'll cut past where that bottom ledge isn't there yet, but when it's gone, there won't be any more material left on this side of it. So z minus 1.050. All right, so easily done. G1 feed rate, P41. Cutter radius compensation left. We're going to feed up to the exact geometry now and feed around it really quick. Now, if you guys want, when you're roughing it out here, you don't have to add the chamfers if you don't want. Just try to stay 20 away, 0.0, 20 away from finish pass. All right. So you can say, okay, if I'm going to rough this out, I'd be at y plus 0.020, and then y minus another 20 from this number to be on this side of it, and then x plus and minus 2.630 divided by 2 plus 20. So they just got to come up with 4 numbers. So that way you don't have to do all these complex chamfers anyway. So I'm going to say y0. Let's not do y first. We'll say x 1.315 y0, not p. Don't need a d because the d is still up here. Okey-doke. And then we never did give it a feed rate up here, if I remember right, because we're doing all this at 50 inches a minute, which is going to be hugely problematic. Let's go F 10 inches a minute. Since we're doing 1500 RPM, that would be 10 divided by 1500 is 6 thousandths per rev. And since we've probably got a 3 or 4 flute cutter, it's about 2 thousandths per rev per flute. Pretty easy on it, really. We'll leave that feed rate, what would we say, 10 inches? Yeah, 10 inches, F10 point. And I'm going to see, we're going to go around this way. We'll just feed way over to X 1.285. That is basically this edge minus the 30. And we'll say X 1.315 oops, 315, y minus 0.030. Remember, when we turn on G41, the way we're programming this style of programming, we're just programming the exact geometry, and you would put the radius of the cutter or the diameter of the cutter into your offset registry to make this work. Because if you left it at 0, you're going to have a really small part. Okay, so I'm going to feed down to y minus 1.660. And then I'm going to go a little faster here. X 1.285, y minus 1.690. And we'll feed out, which puts us right at this corner. I'm going to feed over to x minus 1.285. And then we'll be at x minus 1.315, y minus 1.660. All right. Better save all this hard work. Let's see, we haven't really done a whole lot. It's funny how quickly Mastercam will spit out code, like thousands and thousands of lines of code. All right, so then we're going to feed up to y minus 0.030. And we will feed to y0, because remember, we didn't cut this last angle yet. X 1.285, y0. Beautiful. Then we'll just G40 out, 100 thousandths away from the part, which is going to be y point for x, wherever we started in from. X minus 1.790, y 0.475. All right. Now we'll say G0. That way we can be done with this up, and then next week we can start in on OP2, which is going to be cutting this step. We're going to add these two counterbores with the screws and probably finish the part out, really, because all we have to do is mill this flat. Depends on how much time we get rabbit trail with Mastercam, I guess. So for rough password programming, yes. Exact dimensions plus 0.020. And also, you don't have to put the angles in unless you want to. It should be pretty close to this format. If you want to add the angles, you would basically just add 20 thousandths to each X and 20 thousandths this way in Y and 20 thousandths that way in Y on this side. So you copy and paste it and just add 20 to most of the dimensions. Yeah, like this one would be Y minus 0.050. Might even be easier than just plotting the square because you've already got the format. All right, let's see, 0, Z1 point, M9, that same 1 point, just kind of a bookend thing. And then G53, Z0, 3, Z0, M5. So it takes a little bit longer to program simple things, I think, than it did in Mastercam. I wish I could post this. I'm going to figure out what's going on there because I've always been able to post. Anyway, let's look back at this and this. So your all's homework is to do this pass, and there's just a couple extra more lines in here. Figure your, yeah, you would put in the fill in the blanks, basically. I did this one for you, so. All right, so I'm going to save that, and after class, I'll upload that. In the interest of keeping your time valuable here. The big homework is this. I still don't think any of this will take you shouldn't take you 2 hours, but if you do have questions, also feel free to text. Since we're done with this for now, I'm going to minimize it and maximize this. So just kind of a review. So this part is basically what you're doing is drilling and counterboring the holes. And everything's absolute from this corner. This is your origin point, and it's nice because most everything is dimensioned from that point as well. So it should be kind of cut and dry as far as where your points are. So there'll be these exact numbers. But you want to follow the directions with the format, with the depth, drill to a depth of 200. Remember, these are all can cycles. So like a spot drill is going to be a G80 something. A 1/4 inch drill is going to be a different G80 something. And then the flat end mill, that's going to be for the counterbore, which is these features right here. And if you're not familiar with that, that's 100% for putting screws into the a part and having the head of the screw flush with the top, so that when you move your hand over the top of the surface, that you won't feel the screws protruding out of the top. And you see that a lot in manufacturing. There are here's that example. You don't have to use this, but here's that example of using IJK for a deep drilling cycle. And basically how that works is your I is your first peck. Like if you're drilling through, this can save a lot of time. It's one thing I like about Haas that most other machine tool builders do not do this. Haas is the only one that I know of. If you're drilling a 2-inch deep hole, you can probably get away with a 1/2 inch, peck on your first peck. So that would be your I. Your J would be how much each peck is reduced by for every subsequent peck. So if you had a J of 0.1 and your I was 0.5, your first peck would be 0.5, your second peck would be 0.4. And that makes sense because as you go deeper into the part, you really need to evacuate the chips more frequently and get coolant to the tip of that drill more frequently. And then the K is the very least amount that you ever want it to get to. So once it gets down to 150 or 200 thousandths for each peck, you can say, okay, stop reducing it. So that's a really neat feature. And I would definitely incorporate that if the Akumas would do it, but they won't. So let's see what you can do with these. And as always, you can resubmit your homework until it's correct. It's got good reason for doing that. It's because I feel like you guys will learn the material a lot better if you're allowed to make corrections on your homework and that. So, does anybody have any questions? Since you guys have quite a bit of homework this week between that and the spring housing, I think we'll call that good. Anybody have any questions at all? Since we got an extra minute or two here, let me bring up the calendar just so everybody kind of knows what we're going on here. I would have sworn there's an academic calendar. Well, I know there is. I just don't know why it won't pop up. Oh, here we go. Calendars. Duh. How about just click on the calendar tab? Okay. quick links. What am I not seeing? So summer and fall enrollment begins next Monday. They did extend the last date to withdraw till changed to May 4th. January, February, March. Yeah, so hopefully none of you guys will feel like you need to do that. And did you have a question?
Yeah.
Yeah. Well, I'll just pull up my Google Calendar because I know that's there. Quick links, apply now. Bear with me for a second. I hate that Gmail does that. Oh man, got my caps on. So I always load everything into my academic calendar or into my own personal calendar. That way I know I get reminders about stuff. All right, so this is today. Okay, next week we will have a live class Thursday night. The 30th is going to be a recorded class. So what that looks like, I'm not sure. It kind of depends how far we get next week. Still got plenty of stuff to program. We may or may not get through it all. It's more important to me that you guys retain the information. And then after that, I think that recording for that Thursday will be pretty much focused on review for the final. So we've got pretty much two more weeks. Let's see. Yeah, today's the 16th. Got one more live class, one more recorded class, and then the final. It seemed like that went by really quick. So, anybody got any questions? All right, let's go ahead and wrap up. I'm going to use the rest of my time to get the recording loaded up and get the homework input into the homework thing for you guys. So, you guys stay safe, and we'll see you next Thursday.
Thank you.